In this chapter, we're going to look at graphing, including graphing functions here, and then later on also graphing linear functions and linear equations. So first, let's start a review of the rectangular coordinate system. So here I just have a picture of the rectangular coordinate system. We also use the term plane, so you may hear someone say the rectangular plane or coordinate plane, and we also use Cartesian after Rene Descartes, even called the Cartesian plane as well. So all three of these terms are interchangeable. Now, we will graph some ordered pairs to start and just kind of practice and review those basic points, and then we'll actually get into functions and equations. So the first thing you want to remember is that you do have two lines here. So your first one that runs horizontally, this is your x-axis. And the one that runs vertically is your y-axis. What you want to notice is that these axes both actually extend in both directions forever, so you could continue making this graph as big as you want to. For your x values, you have your positives on the right. So 1, 2, 3, 4, there's 5, 6, 7, 8, 9. So 10 is actually over here. And then you have your negatives on the left. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and then negative 10 is over here. For your y-axis, your positives are going up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and again, the 10 is up top there. And then you have your negatives going down. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, 8, 9, and then again, negative 10, just kind of labeled funny, is down there. In your center, you have 0 here. And actually, this point is a special point on the graph where those lines intersect. That point is called the origin, and it's the point 0, 0. Now, when we're talking about points or ordered pairs, they're always of the form x comma y, and you can use different variables too. We typically use x and y, but you'll see that as you get into applications, you may choose different variables. So your horizontal axis is always first, and your vertical axis is always second when we're talking about the point. Now, in your point, that first piece here, typically x, we call it the first coordinate, the x coordinate if we're using the variable x, or the abscissa. For the y, we call that the second coordinate, the y coordinate, or the ordinate. So you'll hear those terms interchangeably. And as I mentioned, the origin already. And the last thing I want to note is that the plane is actually broken into 4 quadrants, and they're labeled this way. So this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. And we typically use Roman numerals when labeling our quadrants. And it really just allows us to talk about the graph. You're going to see that your first quadrant, everything is positive, right? You have your positive x's and your positive y's. So sometimes in applications, we'll actually narrow in and just focus on that first quadrant. And then if we're talking about more general equations, we'll do all 4 quadrants. So typically, although it doesn't have to be this way, but typically you either do just the first quadrant or you'll see all 4. Those tend to be the most popular ways to look at the graph. All right, let's practice with plotting some points. Okay, so our first point here is negative 3, 2. Now remember, your x value is first and your y value is second. So in order to graph this, we can start at the origin. And then I'm going to find x equals negative 3 first, which is going to be right here. And then I have y equals 2. Now y equals 2 is here. So what we do is we match up these lines, and we put our point right at their intersection. So that first point, that negative 3, 2 is right here. You can see that it lines up with negative 3 on the x-axis, and it lines up with 2 on the y-axis. Next, we'll do 5, 2. So my x value is 5, my y value is 2. So again, same thing. I just put one point, and it should line up with the 5 on the x-axis, and it should line up with the 2 on the y-axis. 3, negative 4. Okay, now my x here is positive 3, so I'm right here. and my y is -4, so my negatives are down. So I'm gonna go down 1, 2, 3, 4. Okay? And again, that point lines up in both directions. X equals 3, y equals -4. 0, 3. Now this one's a little bit different. I have a 0 here. So if my x is 0, then what happens is you're staying and in that center. You're not moving to the positives, you're not moving to the negatives. And then your y is 3, so we're just going up to +3 here. So this right here is our point, 0, 3. And then the next one's going to be a similar idea. So my x is -1, so I'm going to go over to -1 first. And then my y is 0. So I'm not going to move up, I'm not going to move down. So I'm going to put my point right on the axis. All right, so let's see, -1, 1. So my x is -1, and my y value is +1. Let's use a different color here, just so we can kind of see. So it's going to be right here. Now the origin 0, 0, we already did. It's right here at that center. And then finally, -4, -2. So my x value is -4, my y value is -2. So there are our points. Now, just be careful here. The point 5, 2 is in the first quadrant. The points -3, 2 and -1, 1 are in the second quadrant. In the third quadrant, we have the point -4, -2. And in the fourth quadrant, we have the point 3, -4. Points that are on the axes, like -1, 0, 0, 3, or the origin, are not actually in the quadrants. They're technically on the axes. So you just want to make that distinction if you're talking about points here. If it lies on the axis, we actually don't say that it's in a quadrant. We would say that it's specifically on either the x or the y axis. All right, so let's actually look into graphing equations now. So the relationship between two quantities can sometimes be expressed as an equation in two variables. So as an example, you have y equals 4 minus x squared. So we have a relationship between the x and the y, and we're using an equation to express that and show how they're related. The solution of an equation in two variables, x and y, is an ordered pair. So you do need an ordered pair. And remember, an ordered pair is the same thing as a point. Because you have two variables, right? You have an x and a y, so I need a value for both of those to make a solution. And what happens is, when we plug in the x value and the y value, we still get that true statement. So you have that same definition where a solution is always going to give you a true statement, whether it's a simple equation or a more complicated one in more than one variable. We still use that word satisfy here as well. So if something satisfies the equation, we mean it's a solution. So for instance, here's my example, y equals 4 minus x squared. And I'm saying that this point satisfies the equation. My x value here is 3 and my y value is -5. So what I can do is I can replace my y and my x with those values. So I have -5 and then, let's see, equals 4 minus, and then I have 3, which is being squared. And now if I simplify this, what I get is -5 equals 4 minus, well, 3 squared is 9, and 4 minus 9 is -5. So we do see we get that nice true statement that we're looking for here. So for more than one variable, we can still find solutions, but we write them as a, in this case, we have two variables, so we write them as an ordered pair or a point, because they have to go together. Now, the thing with equations in two variables or more than two variables is that you can typically have more than one solution. Particularly with two variables here, we can actually have infinitely many solutions. So this is not the only point that satisfies the equation. So for instance, the point 0, 4 also satisfies the equation. So if I replace those values, y is 4 here, and x is 0. 0 squared is just 0, so then I do get that 4 equals 4, which is true. So the graph of an equation in two variables is a set of all points whose coordinates satisfy the equation. And there actually are infinitely many of them. So it's not just one or two, but there's infinitely many. We can get as many as we want to. And what we're going to do next is actually show some examples on how to graph those equations.